Alright, here we go with creating some polynomial equations. So, given the zeros, we are going to create the polynomial of the least degree, okay? So, here's how we do this. So we're given the zeros. Let's start with number 2, because it's a little more straightforward first, okay? Okay, so we remember that the zeros and factors are pretty much the same thing. The difference is the zeros, we turn them into factors by doing the opposite, right? So positive 3 becomes x minus 3, because x minus 3 equals 0. That gives us that positive 3. Okay, so we're going backwards now to take these zeros and create an equation. So essentially what we have to do is we have to line up all the zeros as factors. So x minus 3 would be 1. Then I've got a negative 1, so it would be x plus 1. Then I've got a 5, x minus 5. And then a 2, x minus 2. Now I'm going to multiply these all together, okay? So various ways you can do this. So we get x squared, 1x, negative 3x, and negative 3. So I get x squared minus 2x minus 3 times, then if I multiply those two together, so x and negative 5, x and negative 2, I get x squared, negative 5x, negative 2x, and positive 10. So I'd have x squared, then negative 7x, plus 10. And so now I need to multiply these ones together, and that'll give me my polynomial. And that's all there is to it. Of course, I say that's all there is to it, but you know, it's definitely going to get more difficult. So x squared times x squared is x to the 4th. Negative 2x times x squared, negative 2x cubed. Then negative 3x squared. Negative 7x cubed. 10x squared. Positive 14x squared. Positive 21x. Negative 20x. And negative 30. So for our first one, clear some space here. Okay, we end up with x to the 4th, because we have 4 zeros, right? So x to the 4th, then minus 9x cubed, then 10 and 14 is 24 minus 3, positive 21x squared, then just 1x minus 30. So there's my 4th degree polynomial. So basically you just make these into factors, then it's just multiplication, okay? And that's really what it comes down to. So we may not do all these problems here in the notes, just enough to get us going. So what do we do now when something has a multiplicity, okay? So 1, so our root would be 1, so it would be x minus 1. Now multiplicity of 2 means that one's squared, and then we'd have x plus 5. So x minus 1 squared, okay, it's like x minus 1 times x minus 1. Okay, x minus 1, we get x squared, minus 1x plus 1. So I'd end up with x squared minus 2x plus 1. And that's all being multiplied by x plus 5. So then I'd make another area model. Now you can multiply using FOIL or any other way that you like to multiply. You don't have to do it this way, but this is just the easiest way that I can think of to do it. So then we just multiply, and then we get x cubed plus 3x squared minus 9x plus 5. And there's my polynomial for number 1. Alright? Okay, so we can see that it's just kind of a lot of work taking these and turning them into factors and then multiplying. Okay, so we've got some factors here for number 3, so we'd go x plus 2 times x minus 1 times x minus 1, or not minus 1, minus 3 times x plus 3. Okay, so then we just multiply them together. So I do x plus 2, x minus 1, and we've also got x minus 3, x plus 3. So x squared, negative 3x, positive 3x, and negative 9, those would cancel out. So these two would end up being x squared minus 9. Okay, and we get x squared, 2x, negative 1x, and negative 2. So we'd get x squared plus x minus 2. Then we multiply those ones out. So x squared, negative 9, x squared, x, and negative 2. So we get x to the 4th, x cubed, negative 2x squared, negative 9x squared, negative 9x, and positive 18. So my polynomial is x to the 4th plus x cubed minus 11x squared minus 9x plus 18. And there's my polynomial for number 3. Okay, so hopefully this doesn't look too difficult, but it'll get a little bit more complex. These are the easy ones, okay? Now if I look at number 4, I've got x plus 5 with a multiplicity of 3. Okay, now if you remember that binomial expansion, you could use that in this case, but for most of it, it's probably just going to be just as easy to go. Just x plus 5, get that one out, and just multiply that by x plus 5 again. This would be x squared plus 10x plus 25. And then I'd multiply that by our last x plus 5, because that would give us 3x plus 5, so we're multiplying by. So x plus 5, x squared, 10x, and 25. So that'd be 125, 50x, 5x squared, 25x, 10x squared, and x cubed. So I'd have x cubed, then 10 and 5 would give me 15x squared, 25 and 50, 75x plus 125. And there's my polynomial. Okay. Now, I'm only going to do, I think, 2 of these ones. Okay. So we won't do those 2 bottom ones. But with fractions, they're a little bit trickier to begin with. Okay. So you have to think of it like this. X equals negative 2 over 5. Okay. Now if I'm changing it back to a factor, I would multiply by 5. So I'd get 5x equals negative 2, because those would cancel. Then we'd add 2, so I'd go 5x plus 2. Okay, that would be my factor, 5x plus 2. Okay, so that pattern goes like that. The denominator is the x value, so I get 5x plus 2. Then I'd have 5x minus 3, because that's a positive. We do opposite, and then 5x plus 4. And it would look like that. Okay, same with number 6. Negative 5 over 2 would be 2x plus 5. Negative 1 over 4 would be 4x plus 1. And negative 4 over 5 would be 5x plus 4. So the denominator multiplies by the x, and then we add or subtract the numerator like normal. So then we multiply. So 5x plus 2 times 5x minus 3, so 25x squared, 10x, negative 15x, and negative 6. So I get 25x squared minus 5x minus 6. Then that I'm multiplying by that 5x plus 4. So I'd get 125x cubed, negative 25x squared, and negative 30x, then 100x squared, negative 20x, and positive 24. So I get 125x cubed. So once we figure out those zeros, it's the same thing. Plus 75x minus x squared minus 50x plus 24. And there's number 5. Okay, now for number 6, I'm going to multiply it out as well. Okay, so first off, I've got the 2x and the 5, 4x and the 1. So 2x and 5, 8x squared, and 20x. So then, we've got the 5x and the 4, and that'll be 8x squared. 20 plus 2 would be 22x, and then 5. So 40x cubed, 5 times 22 would be 110x. And then 25x, then 32x squared, 88x, and 20. So I get 40x cubed, oh, that's an x squared, isn't it? Plus 142x squared, plus 113x, plus 20. Alright, so that should seem fairly simple, even though it does take some time, right, to do that. But now let's start dealing with some of these square root ones and complex or imaginary ones. Okay, this is where things get a little bit crazier. Okay, because with these irrational or these square root and with the complex ones, it doesn't always give us the zeros. Okay, because we always have to have the positive and the negative version when we're dealing with roots. So like this is the positive, this is the negative. Now I only have one version of the positive, the 6, so I have to keep the negative square root of 6. So I actually have 4 roots instead of 3, 4 zeros instead of 3. So then it becomes, for the factors, it would be x minus the square root of 6 times x plus the square root of 6, okay, for both of those. Then we have an x in front of these, so x minus 3 plus the square root of 2. But because we're doing the opposite, this is where it gets kind of tricky, okay? Because it's like I had x equals negative 3 plus the square root of 2. So I'd have to add 3 and subtract the square root of 2. So I'd end up with x plus 3 minus the square root of 2 as my factor, instead of minus 3 plus the square root of 2. Then on the second one, okay, same idea. This one they would have to both add. So I'd end up with x plus 3 plus the square root of 2. Okay, this is where it gets kind of tricky because of all those extra pieces and doing the opposites with the factors. Okay, then we have to multiply. And we don't always like to multiply these ones, but they end up ending up not being too bad because of one thing that happens. Because we have the minus and the positive version of square root of 6, we're going to get x squared, negative square root of 6x, positive square root of 6x, and then square root times square root gives us a negative 6, because the square roots, essentially eliminate each other. And then we look at these two, one's positive, one's negative, so we end up with just x squared minus 6. Okay? So we actually got rid of our radicals there. Now these ones, it'll give us kind of the same thing here. Okay? So x, positive 3, negative square root of 2. X, positive 3, positive square root of 2. Okay, so x squared, 3x, negative square root of 2x, 3x, 9, negative 3 square roots of 2, x square roots of 2, 3 square roots of 2, and square root of 2 times square root of 2 is 2 with the negative in front. So these two will undo each other, and these two will undo each other. So we once again got rid of the square roots, and we're left with x squared plus 6x, and then 9 minus 2 would be 7, so plus 7. Okay? So those square roots actually end up getting eliminated, and that's because we deal with the conjugates of them. That's pretty much always going to happen, because we always have the positive and the negative version of these. Okay? That's always going to be the case. So you can kind of use that knowledge to help you out. Okay, now we're going to multiply these guys. So we get x squared, negative 6, x squared, 6x, and 7. So x to the 4th, 6x cubed, 7x squared, negative 6x squared, negative 36x, and negative 42. So for number 9, we get x to the 4th plus 6x cubed plus x squared minus 36x minus 42. We end up with that. Okay. Now, that was a lot of work for just those ones, wasn't it? Okay. So we're going to try to do as many of these ones as we can, just to give you those examples. So I've got the conjugates here. So as factors are going to be x minus 2 plus the square root of 10 and x minus 2 minus the square root of 10. Okay. Now this one is going to be x minus 3 minus 2 root 2. Okay. But because I need its conjugate, I need the 3 minus 2 root 2. I'm also going to have x minus 3 plus 2 root 2. Okay. Now, the easiest way is really, again, to just kind of do the area model and see what we can eliminate. Okay. So I've got x, negative 2, square root of 10. X, negative 2, negative square root of 10. Okay. So x squared, negative 2x, x root 10, negative x root 10, negative 2 square roots of 10, and negative 10. Negative 2x, positive 4, and negative 2 root 10. So once again, that would be positive, wouldn't it? Negative times negative. So those eliminate. Those eliminate. 4 minus 10 is going to give us negative 6. That would be negative 4x and x squared. Okay. Now we do it with these guys. And we're going to have the same thing happen, where we're going to eliminate those pieces. So you may find a shortcut and realize that, some of these are always going to have pieces that eliminate. So maybe I don't want to deal with those. So negative 3x, positive 9, positive 6 square roots of 2, 2x square roots of 2, negative 2x square roots of 2, negative 3x, x squared, negative 6 roots of 2, and then negative 2 times positive 2 is negative 4. Square root of 2 times square root of 2 is 2. Negative 4 times 2 is negative 8. Okay, so those cancel. Those cancel. 9 minus 8 will give us a negative 1. So we have x squared minus 6x plus 1. Alright, now I do this one more time, and then we'll end up with our answer. Okay, so that would give us x to the 4th minus 6x cubed plus x squared minus 4x cubed plus 24x squared plus minus 4x. And this is more the FOIL style, and I just wanted to do it just for fun. Minus 6x squared plus 36x minus 6. So then I get x to the 4th. See, this is why the area model can be a lot easier to handle. Minus 10x cubed. 24, negative 6 would be 18, and 1 would be 19x squared. Positive 36 minus 4 plus 32x minus 6. And there's our answer for number 10. Okay, let's do one more of these guys, and then we'll need to move on to the complex ones. So let's do number 12. So square root of 10 means I also have negative square root of 10. So factor-wise, I have x plus square root of 10, x minus square root of 10. Okay, the negative 1 plus square root of 10, I also have negative 1 minus square root of 10. So factors, I end up with x plus 1 minus square root of 10, and x plus 1 plus square root of 10. Okay, now I have to do all the crazy work. So these guys, okay, hopefully on these smaller binomials you've realized it's pretty easy to tell that I'm going to get negative 10 x squared, and those are going to cancel out. So I get x squared minus 10. Okay, on these ones it's a little bit harder to see, but we can kind of see the pattern. I'm going to get x squared, 1x, negative square root of 10x, positive square root of 10x. So this would be the negative, this would be the positive. They're going to cancel each other out. Trying to show it to you in a little quicker manner. 1 times 1 is 1. These two are going to cancel each other out, and then we'd end up with negative 10. So I'm going to get x squared plus 2x minus 9, because 1 minus 10. Okay, then I do this last little piece. X squared, 2x, negative 9, x squared, negative 10. So I get x to the 4th, 2x cubed, minus 9x squared, negative 10x squared, negative 20x, and positive 90. So we end up with x to the 4th plus 2x cubed minus 19x squared minus 20x plus 90. And there's the rationals. Now, I've only got 5 minutes left, so we may not get through all these too well. But when we deal with the complex, the imaginary, same idea. I have a negative 3i, means I also have a positive 3i. I have a negative positive I, also have a negative I. So my factors are going to be x plus 3i, x minus 3i, x plus I, x minus I. Okay? And when I'm dealing with, you may remember the pattern. We had the a plus b times a minus b. Okay? When we multiply that out, we get a squared minus b squared. Okay? That's what we're going to end up with. Right? So on these first ones, we can use that to help us. So I'd end up with x squared minus 3i squared. Okay? And 3 squared is 9. And then we have I squared. Now, the thing with I squared, I is the square root of negative 1. So if we square that, we end up with negative 1. So we actually, this becomes negative 1. So I'm times by negative 1, which times that by negative 1, it'll make it a positive 9. So I end up with x squared plus 9. This one we get x squared minus I squared. I squared being negative 1, so it would be plus 1. So I'd have x squared plus 1. So if I take this and go x squared plus 1, x squared plus 9, we get x to the 4th, x squared, 9x squared, and 9. So my answer to this one is x to the 4th plus 10x squared plus 9. Okay, so that one was a little bit easier just because we could use that shortcut. Okay, it gets more complex like on number 16. So negative I again. So I've got x minus I and x plus I, which I know those ones reduce to x squared plus 1. But for the 3, it's going to be x minus 3 minus 3i, and then x minus 3 plus 3i. Because we're going to have the 3 plus 3i here as well. So that one's going to be a little trickier when we multiply it out. But it works a lot similar to the square root ones. Because we get x squared, negative 3x, negative 3xi, negative 3x, positive 9, positive 9i, 3xi, negative 9i, then negative 9i squared. Then, positive and negative cancel, positive and negative cancel. I squared is really negative 1, so negative 1 times negative 9 is a positive 9. So 9 and 9 would give us 18. Then negative 6x and x squared. Then we just multiply these ones out. So x squared and 1, x squared, negative 6x, positive 18, so x to the 4th, minus 6x cubed, 18x squared, negative 6x, positive 18. So for number 16, my answer ends up being, let's do it in green, x to the 4th minus 6x cubed plus 19x squared minus 6x plus 18. Alright, now I don't think I'll have time for another one. So the main thing when you're dealing with these radical and the complex numbers, the roots, is that you have to have the positive and the negative version included, okay? And then you get their factors, and then you just multiply everything out, okay? So, hopefully this gave you enough examples, and you'll be able to now take a look at the homework, try some problems, and see how well you can do on them, and then, watch the video to help you out to make sure that you can get everything done that you need to do. So 14 and 13, okay, we'd also have 2 minus 2i, 1 minus 2i. So factor-wise, it would be x minus 2 plus 2i, and x minus 2 minus 2i. And then x minus 1 minus 2i, and x minus 1 plus 2i. and then you'd multiply them all out. Okay? So get to work on that homework and see what you can do.